Hello and welcome to the Histogram and Fitting tutorial. Today, we will be going over the step-by-step process to make paper-ready histograms. First, select the data file to be histogrammed. The application only supports Excel files. The name of the file imported appears in the Files tab. Next, if the selected file is an extended parameter file originating from the HyperExtract2, select the Data Loaded from HyperExtract 2.x radio button. This enables the X parameter drop-down menu from which the parameter of interest to histogram can be selected. For all other file types, use the column X index to specify the data column that needs to be analyzed. The data of the selected column can be formatted using the input form of X field. This takes standard MATLAB input form. For example, forms such as log, exponential, multiplication can be shown as demonstrated here. The time column is optional and only applicable when multiple files are loaded as shown later. In step 3, you can select one of 5 binning strategies using the binning rule drop-down menu: square root, Sturges, Rice, Scott, and Friedman-Diaconis. Bins can also be set manually using the Manual Bins radio button. You can also normalize the data using the normalization method drop-down menu, which contain options such as count, probability, percentage, count density, cumulative counts, PDF, and CDF. In step 4, you can set the limits automatically or manually. Options are grayed out when not available due to other selections. In step 5, you can set the plot title, include or exclude it, and change the font size. In step 6, you can toggle aesthetics of the histogram. These options include font sizes, grid type, face color, opacity of faces and edges, X and Y labels. The X and Y labels take standard MATLAB input form. If the Use Default Colors radio button is selected, the face color is dictated by the selection of the face color drop-down menu. However, if a user wants to use a customized color, deselect the Use Default Colors radio button, which will enable the face color matrix field. This takes a 3-number input ranging from 0 to 1 corresponding to the red, green, and blue components of the color. The options plot spacing, min plot spacing, auto-adjust plot spacing, and smoothing are only applicable for ridgeline plots. We will discuss these shortly. In step 7, you can select Fit line attributes. This includes line width, line color, and line style. If you want to use a custom color for the line, deselect the Use Default Colors radio button, which will enable the line color matrix field. This takes a 3-number input ranging from 0 to 1 corresponding to the red, green, and blue components of the color. In step 8, the ticks and box options are available. To enable manual ticks, deselect the Auto Ticks radio button. The tick nomenclature is the whole number indicates the number of ticks, and the decimal indicates the number of decimal places for a given tick mark. Use the box on to create a box around the plot whose thickness is governed by box thickness field. In the panel below, further options are provided for ridgeline plots. To demonstrate the utility of this, let's select ridgeline from the plot type drop-down menu, set data segmentation rule to plot count and data segmentation value to 5. Since the y-axis on the left-hand side of the ridgeline plot shows the plot number, the user can opt for an additional y-axis on the right-hand side to show the y values of each histogram using the double y-axis option. The global y-max sets right-hand side y-axis of all histograms to a common maximum value. The y-labels and ticks can be changed using y-label and y-ticks fields. The tick nomenclature is the whole number indicates the number of ticks, and the decimal indicates the number of decimal places for a given tick mark. If you want to save your plot preferences, click Save My Preferences button. If you want to load a set of preferences, click Load My Preferences button. Now let's look at histogramming options. For a single histogram, navigate to the 1D histogram panel. If you want to perform fitting on the histogram, click the Perform Fitting and Overlay on Histograms radio button, then choose your model of interest using the Fit with drop-down menu. When GMM is selected as the model, use PDF normalization. If not, suboptimal fitting may occur, which the app will warn you of. There are 2 options that are grayed out in the Data Fitting tab: X in log and Forced X cutoff. X in log becomes active when we choose the log normal option. In the log normal option, if the X data is already in log scale, click the X in log radio button. Otherwise, the program will convert the data into log scale. The forced X cutoff becomes active when the exponential tail option is chosen. If you click Force X Cutoff, you will see a field enabling with the label X. Here, the program essentially eliminates any data points below the bin defined by the field X or bin with the highest counts. Afterwards, click Estimate Seed to generate a set of initial values that serve as the initial guesses of the fit. Note that Estimate Seed is not supported for GMM. Thus, the value for field P, which stands for population, should be updated manually. Afterwards, click the plot button, then the histogram, and its fit will appear, and the fit parameters will appear in the table below. If you select multiple files, use the File to Plot field to choose the file to be histogrammed and fitted. To demonstrate this, let's choose 2 files. The pop-up allows you to either analyze the chosen file individually, combine the chosen files into a single file, combine the chosen files with a single file in ascending time order. For this last option to work, the chosen file should have a time column. The time column is defined using the time column optional field in step 2. Let's select single Gaussian as the fit model and set the normalization method as count. Now let's select file 1, click Estimate Seed Values and click Plot 1D Histogram. Now let's try file 2. If I enter a value greater than the total files in the File to Plot field, it defaults to the maximum value. In this case to 2. If I enter 3 in the File to Plot field, the second file will be plotted. To view the files loaded, navigate to the Files tab, which shows file number and the file name. Now let's look at multiple histogram plotting and histogram. This can be from multiple files or from file subsecting. Let's first look at file subsecting. This is only available for single files. This option also becomes available when multiple files are loaded and combined. As seen, when a single file is loaded, the fields in Step A and Step C panels, which is for data segmenting, becomes enabled. However, when multiple files are loaded, these options become disabled. Similarly, when multiple files are loaded and combined, these options become available again. Let's now choose a single file. Files can be subsected based on event count, plot count, or duration using the Data Segmentation Rule drop-down menu. Let's select plot count and set the data segmentation value to 5. This will create 5 histograms. The Skip Last button enables the removal of the last histogram. This is a useful option if the last histogram is lacking data points after the data splitting. Click Populate Table to see the number of plots and their event count. The adjacent table shows the segmentation that is taking place. The angle and labels for these plots can be modified in Step V panel. The axis labels can be set using the Text Area Titles axis labels, which take standard MATLAB input form. You can change the plot type and viewing angle of the waterfall plot type using View Y and View X fields. The table shown in Step D can be saved using the Save Table button in Step C. Similarly, a table can be imported using the Import into Table button. The table in Step D is only editable with duration as the data segmentation rule. Let's set duration as the data segmentation rule and 20 as the segmentation value and click Populate Table. We can change the entries in second column as we like. After making a change, click Update Table. Let's set data segmentation rule to plot count and to data segmenting value to 5. To fit multiple histograms, navigate to the Data Fitting tab. Fields and operations are similar to what we saw with 1D histogram fitting. To reiterate, click the Perform Fitting and Overlay on Histograms radio button, then choose your model of interest using the Fit with drop-down menu. When GMM is selected as the model, use PDF normalization. If not, suboptimal fitting may occur, which the app will warn you of. There are 2 options that are grayed out in the Data Fitting tab, X in log and Forced X Cutoff. X in log becomes active when we choose the log normal option. In the log normal option, if the X data is already in log scale, click the X in log radio button. Otherwise, the program will convert the data into log scale. The Forced X Cutoff becomes active when the exponential tail option is chosen. If you click Forced X Cutoff, you will see a field getting enabled with the label X. Here, the program essentially eliminates any data points below the bin defined by the field X or bin with the highest counts. Afterwards, click Estimate Seed to generate a set of initial values for each histogram and are displayed in the adjacent table. When GMM is used as the model, the seed values are populated only based on the field P. They are never optimized unlike other models. The single average seed averages the seed values in the table and uses a single set of seed values for all histograms. Let's select Single Gaussian and estimate seed values. The initial guesses to fit the 5 histograms are shown in the adjacent table. Now let's navigate to the Multi-Histogram tab and click Plot Histogram button. Both the histograms and fit lines appear. The fit values can be seen in the table under the Fit Values tab. If you want to view individual histograms, navigate to the Single Histogram View tab and input the histogram number of choice in the View Histogram field and click View Histogram Fit button. The table below also gets updated with the fit values corresponding to the viewing histogram. Now let's navigate to the Bar Plots tab. Bar plots based on amplitude, mean, mode, and standard deviation can be plotted through the selection of Plot Metric drop-down menu. Click the View Bar Plot button to view the bar plots. You can use absolute values, change the bar width as needed. The plot population and population options are only available for GMM model. If the Use User-Defined Face Colors option is selected, use the Face Color or Face Color Matrix option in Step 6 to set the colors. The plot limits, labels, tick angle, and tick labels are also editable. Data can be both exported and imported from and to this table using the Export Table and Import Data buttons. Now let's navigate to the Normal tab. In this tab, you can plot QQ, box, and violin plots. Their labels and title are also editable. The limits of the QQ plots, box plots, and violin plots can be adjusted using the panels below. The ticks can be set using the Ticks panel. By default, all plots are set to have auto ticks. The tick nomenclature is the whole number indicates the number of ticks, and the decimal indicates the number of decimal places for a given tick mark. Now let's navigate to the Statistics tab. Note that this is a beta version and only be used for multiple files. After selecting multiple files and selecting the X parameter or setting the column X index from Step 2, choose the test type from the Test Type drop-down menu using the table above as a guide. Step 3 shows you the corresponding p-values. The adjacent table shows the mean and mode of fits and can be populated using the Populate button. Values can only be viewed if fitting has been performed. The population field is used with GMM models to select the population of interest to view. The application allows further plot fitting and customization through custom coding. Now let's navigate to the Custom Histogram Fitting Single tab. In here, the 2 text areas are dedicated for single histogram fitting. The left area is for code that governs seed values or initial guesses for the fit, while the right is for the actual fitting. Thus, with this, models that are not available in the application can be used for fitting. The scripts can be saved and loaded using the Save and Load buttons. To enable the use of these custom scripts, navigate to the Main tab, then to the 1D histogram panel, and click Perform Fitting and Overlay on Histograms, and then select Custom from the Fit with drop-down menu. Now let's navigate to the Custom Histogram Fitting Multiple tab. This is similar to the previous tab, but for multiple histogram fitting. The scripts can be saved and loaded as needed. To enable the use of these custom scripts, navigate to the Main tab, then to the Data Fitting panel, and click Perform Fitting and Overlay on Histograms, and then select Custom from the Fit with drop-down menu. Now let's navigate to the Custom Histogram Styling tab. The 2 text areas are for single and multiple histograms. They can use to further customize the appearance of the histograms. By default, the example code is grayed out. The scripts can be saved and loaded as needed. The Plot 1D Histogram button and the Plot Histogram button are linked to the Plot 1D Histogram button and the Plot Histogram button in the front panel. This brings the tutorial to an end. Thank you for watching.